Alrighty, welcome back to linear algebra. Let's jump into Anki. I did do Anki yesterday, even though I didn't make a video. I ran out of time, but that I did do. We just have one flashcard then. What is the standard matrix for an orthogonal projection onto the x-axis in R2? 1, 0, 0, 0. All right. Then I'll go ahead and grade the last problems I did, and then go from there. All right, all the problems were correct, and so I'm going to continue doing a more practice problem now, and I'll talk to you in a bit. All right, we just knocked out a lot more problems. First of all, we finished up this problem. I don't know what number this was, showing that basically reduced row echelon form does not equal I, therefore that standard matrix is non-invertible, and therefore the transformation is non-invertible. All right, then we did a review problem from 1.7, basically saying that if A plus B equals a symmetric matrix, then A and B are both symmetric matrices. We said false. Just look at this counterexample. There you go. These two are not symmetric. This is symmetric. The 19 back to 1.9. Basically, a lot about invertibility. Is this basically, we pulled this from a matrix form. Just checked as if it is invertible. Yes, it is invertible because AD minus BC does not equal 0. Then we found the inverse standard matrix. By taking this, which is 1 over this value, times D, negative B, negative C, A. That's this. And then finding T, the inverse transformation of W1, W2. So we took the inverse standard matrix, times that by W1, W2, and there's the final value, or final matrix. 21A basically was saying, is this given geometric kind of transformation invertible reflecting over the x-axis in R2? I said yes, that is invertible. What happens? It reflects over the x-axis again. The same question for 21B was 60-degree rotation in R2. I said yes about the origin in R2. Yes, it is invertible. It will result in a negative 60-degree rotation about the origin in R2. 21C, what was this? Basically projection onto like some kind of orthogonal, like x equals y equals x, or something like that, one of the axes. No, non-invertible. 25A, given this standard matrix, what does this do? What does this do geometrically? And so I just plugged in an example, 5.510, just rough line there, and we see that it reflects over the x line y equals x, then also over the y-axis and also over the x-axis, and you can do that in whatever order you want. So that's that. 27 then was what I was working on. Proof basically showing that if TA and TB are matrix transformations, that they commute if and only if A and B commute. So we're in the process of showing that. So that's it for today. Talk to you tomorrow. See ya.